Sds-Page is a gel electrophoresis technique used for protein separation after treatment with SDS. The proteins of a sample can be separated due to the difference in their molecular weight. A sample containing a variety of different proteins can be analyzed. Sds-Page is a short form for sodium dodecyl sulfate polyacrylamide gel electrophoresis. Proteins in the sample have distinct charges based on the composition of the amino acid side chain. Proteins are folded in various shapes due to the polarity of the side chains and the non-covalent or covalent interactions. When the protein is dissolved in the anionic detergent, which is SDS, the proteins are denatured. The disruption of the non-covalent bond leads to the unfolding into linear chains with negative charge proportional to the polypeptide chain length. It is the intention of the SDS to make the protein similar in charge and separate them solely on their molecular weight. But before that, proteins might be also treated additionally with beta-mercaptoethanol. It acts as an enzyme reactivator in system, necessitating reduction for activation, and has been commonly used to reduce disulfide bonds in order to separate protein subunits for the use in electrophoresis.
To prepare the protein sample for electrophoresis, pipette 25 microliter of BSA to protein solution, then add 25 microliter buffer containing SDS. The function is to break the hydrogen bonding present in protein molecule. Then gently flick the conical vial to mix the solution. Add 4 microliter of 1 molar dithiothiazole DTT to the solution. DTT break the disulfide bond present between the amino acid and protein. Again, flick the conical vial to mix the solution. Boil the sample solution in 90 degrees Celsius water for 5 minutes. After preparing sample, we need to do gel preparation. First, place dry spacer plate and short plate in the casting frame. Make sure the short plate goes in front with the arrows on spacer plate facing up. Then, place the casting frame in the casting stand. After that, prepare the separating gel. First, add 1.65 ml of distilled water to a 10 ml conical vial. Then, add 2 ml of acrylamide mix. Add 1.25 ml of 1.5 molar tris with pH 8.8. Add 5 microliter of SDS. Mark the glass 1 cm below the teeth of the comb as the guide to add the separating gel. Add 50 microliter of ammonium persulfate, ABS, and 3 microliter of TMAT. Once the ABS and TMAT are added, the solution will start to polymerize, so try to add them as quick as possible. Then, gently vortex the solution. Add the separating gel solution into the gel cassette by using the pipette. It is recommended to leave a little bit of solution in the pipette to avoid introducing bubbles. Fill the solution until reach the mark. If air bubbles exist, add a layer of isopropanol on top of the gel. While waiting for separating gel to polymerize, make the stacking gel. First, add 1.7 of distilled water to a 10 ml conical vial. Then add 415 microliter of acrylamide mix. Add 315 microliter of 1 molar tris with pH 6.8. Add 25 microliter of SDS. After the gel has polymerized, dry the layer of isopropanol. Add 25 microliter of ABS and 3 microliter of TMAT to stacking gel solution. Then gently vortex the solution. Fill the rest of the plate with stacking gel solution to the top. Insert comb between the plates. Let gel to polymerize for 40 minutes.
When the gel is polymerized, the plastic comb is carefully removed so that the lowering wells won't be impaired. Next, water and foam left after the polymerization are dried using the filter paper. The prepared gel is placed in the gel electrophoresis apparatus. The wells are loaded with the protein samples. The bromophenol blue dye is added to the samples. Being a very small and highly mobile structure, it moves ahead of most proteins. Being a very small and highly mobile molecule moves ahead of most proteins. When the electric field is switched on, bromophenol blue will move much more quickly, thus indicating the front line or the electrophilis or the electrophoresis front. One of the wells is loaded with a standard sample containing a series of proteins with known molecular mass. The molecular mass of the proteins being studied is determined by comparing their mobility with those of the proteins in the standard sample. The addition of the electrophoresis buffer is carefully performed using a pipette, first into the loading wells and on top of them. The glycerol added to each sample increases the solution density, thus allowing the sample to sink to the bottom of the well. Then, the rest of the buffer is poured out into the electrophoretic chamber. The chamber is closed and it is connected through the rectifier to the power source and the current is switched on. The electrophoresis is carried out at 60 volt for about 15 minutes until the sample enters the stacking gel. Then 120 volt are applied to the gel for movement in the separating gel.
Hello, my name is Mohamad AFANDI. I will continue with the step 3. Run the Sds-Page in the criterion cell. The negatively charged protein will move to the anode due to their charge per unit length is the same. The movement of protein separations are determined by the molecular weight or by the molecular length. The smaller the protein, the easier for it to move through the gel pores. The larger molecule is hard to move due to the deceiving effects of the gel. The smallest molecule of bromophenol blue dye pass through the gel pores fastest. The electrophoresis is run until the dye reaches the bottom of the cassette, then it will be turned off.
And then we need to remove the lid and takes all the inside chamber and carefully pour the buffer. The next step, we remove the glass plates carefully because the plate very fragile and can be break easily. Later, we need to crack open the gel cassette using a special tools. It is to detach the plate from each other. And then, we float the gel off out of the plate by immersing it in distilled water and gently shaking using rotary shaker for 5 minutes. After that, we scrape the gel off the plate. And the gel was rinsed twice with distilled water for 10 minutes each time. We use Comisi blue stain for this gel staining. We transfer the gel into the Comisi blue stain and make sure the gel is covered by the stain. Then gently shake the gel for about an hour. After an hour, we destain the gel using distilled water and shake gently for at least 3 hours. The excess stain in the gel starts to come out and the bands of protein will appear. This is the close-up of the protein bands and you can see the marker lines clearly visible with define the molecular weight. That's all from us, thank you.